Alrighty. Is it on now? All right. Let's pull up Handy Dandy's MyLab Plus. Let's see where I left off. As I said in the last class, at the end of class, you should be working on 5.A, whatever they call these sections in this book, 5A, 5C, and 5E. Thank you. Okay, that's the homework you should be working on because it goes with the reading that we're going over right now. Probably get into chapter 6 today, don't know. I think we were starting frequency distributions. I can't remember, but we'll go ahead. I think it was 5C. So that's the second time I've told y'all that y'all should be working, reading, and working on problems in chapter 5, right? I think that's the second or third time I've said that. Yeah. Frequency distributions, we've already started on that. Make sure you know what a frequency distribution is. Make sure you know what relative frequency is, and that's the number in the category over the total. Sometimes you multiply that by 100 to get a percent. Sometimes they just want a decimal, so make sure you read the directions whenever you're talking about a relative frequency and what type of answer they want. Okay? And I will show you how to use Excel in just a few minutes when we go over one. We talked about qualitative data and quantitative data. We talked about quantity, not quality. We talked about people that are inventors putting together things for quality, and then after a while the quality starts to diminish and the quantity starts to take over. And we talked about that. I think this is where we left off, but we didn't get into bar graphs and pie charts. There's a lot of things that are used in statistics, pie graphs, bar charts, histograms, line charts, all kind of different visual representations of data. The only thing in this section in 5, whatever this is, 5C, is to make sure you know which is which. Okay. They may ask you to read it, and we'll talk about that a little bit. But things on graphs, you might want to write these down. This is on page 313. Of course, it's got to have a title, vertical scale and horizontal scale title, and the legend. It's kind of like a map. Not really, anything new there. Pie charts, when you're deciding the pie chart, and when you want to know what size the wedge is going to be, you take the relative frequency and you multiply it by 360 degrees. Now that's important. Whenever you're drawing a pie chart, and most of the time in statistics, marketing, business, anything having to do with outcome, you're going to be dealing with a pie chart. Outcome for a hospital would be dead patients versus patients that are not dead. Okay? I'm sorry if dead offends you, but dead is dead. Okay? It's not live. I don't know how else to put it. If you're talking about a widget company, then you're talking about how many widgets are being put out, so many dollars per widget. So you're talking about cost versus revenue versus whatever. Okay, so pie charts are used a lot. And it's kind of hard to mess up a pie chart. It's kind of hard to make a pie chart biased. You can make other things biased, and we'll talk about that when we talk about what they're called. They're called graphics. I can't think of the name of it, but they make a barrel of OIL this big and a barrel of OIL this big, and they try to make that into statistics. And the barrel is 3 times bigger than the other barrel, but it's 5 times more, and it just doesn't line up right. And we'll talk about that in a few minutes. But here's a pie chart. And the way that you read a pie chart is if you got I don't know what these are, but this A, B, C, D's, and E's and F's. So if I want to know how many people made A's and there's 30 people in the class, then I take 16% and multiply it by 30, and that gives me how many people were made A's in the class. 8% times 30, 12% times 30, 36% times 30, and 28 times 30. If you take all those numbers and add them up, it should equal what? 30. How do you read a bar chart? This is a bar chart. Histogram, the bars touch each other. Bar chart, they don't touch each other. That's the only difference between the two. So how do you read this? Well, this is 4. This is 7. This is 9. This is 3. And this is 2. And I'm reading the left side. That's the frequency. Now, relative frequency would coincide with this number right here. What's the total? Well, there's 4 here. There's 7 here. That's 11. 11 plus 9 is what? 20. 20 plus 3 is what? 23 plus 2 is 25. So there's 25 people in the class. Okay? Add the tops. So 2 divided by 25 multiplied by 100 is 8%. 3 divided by 25 multiplied by 100 is 12%, and so on. Bar chart, bar chart. Pie chart. And I'll show you how to do that on Excel in just a few minutes. This is a histogram. The difference between this and a bar chart is the bars touch each other on a histogram. Now, a lot of people say, well, that's kind of goofy. Yeah. I wouldn't spend a night's sleep worrying about it. I mean, it's not like you're going to fail the class if you put the bars too close together or something. It's not a big deal. Bar chart and histogram is essentially the same thing. This is a line chart. Same as bar chart, except it doesn't cover as much area. Okay? And I realize that a lot of these things are elementary. That's why I don't spend a lot of time going over chapter 5. A lot of time, students can extract the info that they need to extract by reading. Unless you're one of these people that can't find your way out of a wet paper sack. Okay? Or you're protesting and you don't even know what you're protesting. And I'll show you how to do that in Excel. There's examples of bar charts, line charts, and that's 5C. Next is 5D. I think that's when we actually start getting into doing some frequency distributions. Is it 5D or 5E? 5E? I'm getting there. I think I'm in the homework right now for 5D, so that means 5E is coming up. There it is. Correlation. Cause and effect. I drink the wine, I have to pee. Any of you ever seen the second or third, I can't remember, Matrix? They go to the French restaurant, and there's this guy that's there that he wants Neo wants to see the key maker, and the guy says, everything's cause and effect. They drink too much wine, they have to pee. Correlation, okay? You drink a lot of beer, you have to pee. You drink a lot of water, you have to pee. If I offended anybody by saying beer, I just said water, okay? Either one, they're made out of a lot of water. So if you drink a lot, you got to pee. Cause and effect. If you drive a BA truck or a BA, what do you call them things, SUV, don't expect 35 miles to a gallon. Cause and effect. Heavier the car, the lower the what? Gas mileage. Cause and effect. You can think of a lot of cause and effects. But correlation is basically cause and effect. Correlation is the measure of cause and effect. Okay? Positive correlation means that there is a correlation. Negative correlation means that there's a correlation, but it's not in a good way. No correlation is a horizontal line. Okay? And they'll show you the correlations probably on the next page. Or the next page. There we go. Now, look at this. This is movies. Okay? I don't watch the Avengers anymore. I still like Batman. I don't get into those movies. I never did get into Harry Potter, and I never did get into the Hobbit with the big ears and woods. I never did get into that stuff. The sorcerer stuff, I don't get into that stuff. Some of y'all might, I don't. Pirates, I would like to watch the pirate movies. I've never seen them. I love Johnny Depp. Okay, even though he's out there floating. I'd like him as an actor. Okay, I've never seen the pirate movies because I don't know which ones come first. Now, one of these days I got to Google it and find out which one the series, and then I'm gonna go to direct and I'm gonna watch it because I actually think they're probably pretty good, but never seen them. John Carter, that was about a stupid movie. That was a waste of time. There's two reasons I don't like the Avengers. Okay. Okay. One reason I don't like the Avengers is because there's two on there. You could put a bullet to their brain and they'd be dead. That's the bow and arrow guy and the girl with the 9mm. They're worthless. They're useless. Okay. Why are they even on the Avengers team? That's one reason I don't like them. Second reason, after this last commercial through Hollywood that basically tried to tell America how to vote, Iron Man and his little sidekick and 9mm girl, they can go where for all I care. So I'm not giving them any more of my money. They didn't say get out and vote. They said get out and vote the way we want you to vote because we're people in Hollywood and you're supposed to do what we tell you because we're smarter than you are. So Iron Man and his sidekick, what's his name? Rhodey, that guy, and which it wasn't for Iron Man, nobody knew who that guy was. And 9mm girl, they can all go jump in the lake for all I care. But I still like Batman. I didn't like the last one. Batman versus Superman. It just wasn't. First of all, I didn't think it was ever going to get to the part where they were going to fight, okay? I didn't think they were ever going to get there. I thought they were going to have a dinner before they even did anything. I did like the guy that plays Mark Zuckerberg and the guy that played, what's his name, Lex Luthor. I like him. I like that guy, whoever his name is, until he says something stupid and then I won't like him either. So, but anyway. If you take out a couple of these, you might see a positive correlation. What do you mean? Well, you see something like this. If I was to take the average, called least squares, difference in least squares, and take the difference here and 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 find a middle point, it would be something like this black line right here. That's called a correlation. Okay? Now, which way is it going? Well, how do you know? Well, unless you're from Saudi Arabia, which way do we read? Left to right. Masalama. If you're most of the time we read from left to right. So there's your car. What's the car doing? It's going uphill. That means it's positive slope. You want a negative slope, negative correlation? It's going to go downhill. Draw your car over here. Why don't you draw your car on the right hand side? We don't live in Saudi Arabia. Duh. No correlation would be like that. Now, any variation of those three, you need to decide what it is. Like if the magenta was a little bit this way, then that would be a positive correlation. Not a lot, but it would be positive. If it was a little bit this way, then it would be negative. And you have to remember those three, because all of your test questions or homework questions is going to be based off of those three lines. Okay? Just put your car right here and right here and right here and tell me what it's doing. Simple as that. Unless you want to make it difficult, and believe you me, there's a lot of ways that y'all make things difficult. I can't find my homework. I just make things complicated. That's what it is. It's my fault. And it wouldn't be my fault if the Russians hadn't got in and hacked my MyLab Plus account. I can't get onto the there. Types of correlation, they're going to tell you positive correlation, negative correlation, no correlation. Again, another example. What's this? It's supposed to be a straight line, but that ain't a straight line, is it? What's this correlation? Positive. What's this correlation? Negative. Simple as that. And you'd be surprised on how difficult some people can make that. Don't make it difficult. You hear me, Mr. Harvell? Don't make it difficult. Positive correlation. Both variables tend to increase or decrease together. Negative correlation. The two variables tend to change in opposite directions. No correlation. There's no apparent strength of correlation. How steep a correlation line is. Okay? I mean, you could think of all kinds of correlations. Accuracy of weather forecasts. Positive correlation. Unless you go with the local weather. And the local weather is usually trying to make something melodramatic, so they lose sight of their accuracy to try to scare people half to death. Okay? So that's why I don't watch local news anymore. I mean, they send poor old Nigel out and throw tax on the interstate so they can have a wreck on the interstate. The correlation may be a coincidence. Write this down. This is page 348. The correlation may be a coincidence. Both variables might be directly influenced by some common underlying clause. That would be your weight of your vehicle versus gas mileage. I just don't understand why my Ford Expedition don't get 35 miles to the gallon. When it's packed up loaded with people and I'm going to the beach, we're going downhill. Why don't I get 35 miles to the gallon? You're an idiot. You shouldn't be driving. Okay, you're driving a full-size truck. Is what you're driving. It's an SUV. Yeah, but it's on the frame of a full-size truck. So that means that you're driving a truck. A truck very rarely is going to get 35 miles to the gallon unless it's got a rubber band as an engine. Okay, like a full band. If you got a V6 or more, you're going to get 14 to 20 miles to the gallon if you're driving a BA vehicle versus a Mini Cooper, which you can get like 56 miles to the gallon on a Mini Cooper. And I would a whole lot rather have a Mini Cooper than some electric car. The batteries are going to blow up. And me sitting on them, I don't care nothing about that. What else is there? There's a Volkswagen. How much does a Volkswagen get? A little bug. How much does it get? It gets like 40-something miles a gallon, doesn't it? Okay, y'all not gonna talk to me. Okay. Y'all ain't got no cars. Okay. That's very important that you can be able to do correlation, because I'll give you 3 or 4 of those on the test. And that's chapter 5. Okay, very painless. All right, that's it. How many things did I pull out of chapter 5? Look in your notes and see. Count them. Just round about. How many things did I pull out? Maybe 15 or 20 things. We're talking about 15, 20% of the test. Anything that I cover with definitions, anything I said, you need to write this down. Anything I said, this is a test question. And there's about 15 or 20. How many? Oh, I thought you counted. Did you count them? Okay, you're a loser. You're going to fail. That's why you're going to fail. Nobody counted them. Y'all suck. Anyway, chapter 5, painless. Hopefully you can get all those right. Now let's go into chapter 6. What page does chapter 6 start on? I'll just pull out let me just pull out the table of contents. Chapter 6, page 358. Let's see what we got first. 2 pages on people interpreting, 3 pages on people interpreting, 4 pages. Good. We only need 4 pages to tell us what we're going to learn. Objectives. Now, there is a good question right there. What is the average? If I asked, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 of you in here right now. And if I was to ask you, give me the definition of the average, all of you would say the same thing. It's the mean. Okay, what's the definition of the mean? It's the average. What's the definition of the average? Well, you take all the numbers and you divide them by the number that's in the group. Okay, that's not the definition. That's how you calculate it. But what's the definition of the average? And I have found that that is one of the most not known things that students need to know. And what I mean by that, well, let's take a picture. I'm going to draw a picture here. And I'm going to draw a graph. And this is the definition of a straight line. This is the definition of a average. You got a frequency distribution that gives you the following bar chart. I hope I can do this right, because it's hard to do it when you do it in your head. All right, let's go with rectangle. And let's say this rectangle is at 2. And this rectangle is at 4. Well, that's not going to work. That rectangle is at 4. And rectangle is at 8. And a rectangle is at, so that's 2, that's 4, that's 8. And then let's put one at 6. Let's put one at 2 again. Okay. And of course, this is 2. This is 4. This is 6. And this is 8. All right. And let's say that I take, let's put my handy dandy rectangle, make it red, make it blue. And I take this guy, well, let's see if I can move it. I take this guy and I put it over here. It's supposed to fill in that whole area because it's two, there we go. I took him off and I put him over here. All right. And then I take this guy and I'll make him blue. This guy right here, and that's equal to 4. All right, and I put him, well, I've had so much training on this thing, you'll just have to excuse me. And I put him right here. Okay. And that takes care, and that knocks this out right here. So I take my handy dandy graph and I bring it down here. Okay. This ain't the way it's supposed to come out. But anyway, and then I take this guy, and he's 2 more, and I shrink him down to here. And I bring that 2 that I just made up at the top and put it right here. And then I have another 2 out here, and I put this 2. I told you I didn't do it right. Well, I just added another 2, and I put it right here. Okay, now the whole point of me showing you this is that I've taken all the excesses and all the shortcomings and I filled in all the gaps. Does everybody see what I did? Hopefully you see that. Why? Because I want this number right here. And I'll take my handy dandy line maker and I'll make it thick and I'll make it red. And that's this line right here. Now, what does that line represent? That line represents the number in which there is no variation. Write that down. And whatever that number is the what? Is the mean. Now there's only one thing in our life that has no variation. And what is that? One thing in our life that we have no control over. Time. That's the only thing in our life that has no variation. Why does it have no variation? It's always the same and we have no control over it. Although there are some people that try to have control over it and they cruise them all when they're 40 years old and they dress in teenage clothes when they're a mother of 3 with cancer side. But anyway, they're pretty sad looking. But anyway, some people try to, manipulate time, but you can't. Okay? Time is like this. It's uniform. All right? Now, the mean is the number that represents no variation in your data. Now, why would you want to know what number has no variation? Because then you can compare the individual numbers to that number. No variation, no correlation. Correlation means that something is taking effect on your data, right? And mean, or the average, is the number that nothing is pulling against it or pushing against it or pulling forward or whatever the case may be. In other words, it's not affected. So the best number to compare to is the what? The mean, because it has no variation. You understand? So the definition of the mean is the number at which no variation is represented, or the number that represents no variation. So if you got that previous slide that we had, the previous bar chart where it showed the A, B's, and C's, okay? That was variation all over the place. Got 3 A's, got 14 B's, got 5 C's, got 6 D's, and 3 F's. All over the place. But where there's no variation is the average of those numbers. That's no variation. And then you can compare. That's why when you're in college, what does the teacher always say about the test? He or she always wants to give you the class what? Average. Why? Because you get to see if you're a failure or not. All right. If the class average is 26 and you made a 76, then that tells you that you are a what? You're a winner. You're going to succeed in life. But if the class average is 26 and you made a 7, then that means cardboard box. In a ditch, no job, you're a failure. Why? Because the average is 26. That's where no variation is. Nothing is pulling against it. Nothing is pushing it. Nothing is making it go up or down. It's no variation. That's the number that you compare to. Now, when you see this in statistics, there's 3 numbers that you compare to, and they're called measures of center. Not S-I-N-N-E-R. C-E-N-T-E-R. Okay? Center. All right. There's the mean. There's the median, and then there's the midpoint. If those 3 numbers are close together, then your data is tight. Your data is valid. If those numbers are not close together, then that means you got a 50-year-old 6th grader in there somewhere. Okay? Or a 12-year-old senior at high school. You got something in there that ain't right. You got an age in there that is not the norm. Okay? And you'll see that when we start to when we start to do some Excel spreadsheets, and we start to do some, you're going to see the mean, the median, and the midpoint be close together, and then I'm going to change a few numbers, and you're going to see the mean, the median, and the midpoint. You're going to see it open up. Okay? It's called slop. If you mechanically incline a bearing that's gone, and the axle sitting in there going like this, it's a lot of slop. You don't want slop with a bearing. You want it to be tight. You want it to clamp down on it. So when it turns, there's no slop. If you're talking about statistics, you don't want your numbers to be all over the place. You want them to be somewhat close. That's why if you're in a lab, if you're in a physics lab or a chemistry lab and you're doing an experiment, do you want to write down all 15 times, or do you want to write down the times that are close together and throw out the outliers? You want the ones that are close together and throw out the outliers. Okay? When I was in physics, one of my physics motion, I think it's the second one, we had to make a car out of a mousetrap. Okay? So you had to get, those plastic wheels that you put on box cars in the Cub Scouts. So we got some of those, and we took aluminum nails because they were light. We put those in there, and then we put what we did is we put a gear. We made a gear for our wheel and took a rubber band and put it on the our string and put it on the gear, which was a spool of thread, or what do you call them, spool, a wooden spool, and tied that into the wheel. And the spring on the rack track would pull that string, and the string would make the wheel go, and the car would go. Okay, we were supposed to run a trial of 15 times. And we ran a trial of 10 feet, and we measured the time on that 10 feet to see how fast it would go in miles per hour. But the teacher said, throw away your 5 worst times. Well, why did he say that? Because the car didn't have any steering wheel. Okay? And what would the car do? It'd go off left and right, and go off the what? It'd go off the little racetrack that we made. So some of those times we threw off. Why? Because it would have been 15 minutes, because it went that way before it crossed the finish line that way. So you know, we had to throw that time out. We had to throw out the time that the string came off of the little spring. Okay, so by the time we got through, we had 10 good times, and we did the average, and then we converted it to miles per hour. I think our car came out to be like 3.5 miles per hour. Is it raining? Good. I hope it rains all week. Need the rain. Dang old hayfields. Anyway, that car was going about 3.5 miles per hour. Now, you may say, well, that sucked. No, not when it was running off its own power. It's not bad at all. Okay? But you throw out the 5. So whenever you do an experiment, you don't want to keep every single one of your times. You want to run 25 times and drop the top, or drop the worst 5 times, or run it 12 times and drop the 2 worst times. Usually the outliers are something that went wrong. Okay? So your data is valid. All right, I'll shut up. Let me go back to this. There we go. So, what is the mean, the median, and the mode? I'm not going to spend a lot of time on mean, median, and mode because I know you've heard about mean, median, and mode since you were in the what? 5th, 6th grade? The mean, you add them up and divide by the number. I'm not going to spend a lot of time on that. The median is the middle. Now, the median, you need to make a little adjustment on the median. I'm just going to put it, there we go. The median. If n is equal to an odd number, then you take the middle. So if you have 15 numbers, you count down 7 and you take that 8th number and that's your median. Okay, because you got 7 up and 7 down. 7 plus 7 is 14, plus 1 is 15. 17, 8, 8, and 1. Okay, it's pretty simple. If your number of objects is odd, then you just take the middle number. What if it's even? If n is even, take the average of the 2 middle numbers. Okay. Numbers. So that's the only thing you need to make a note of with the median. With the median. The mode is the number that shows up the what? Most. M-O, M-O. Mode, most. Number that shows up the most. Now, can you have more than one mode? Yes, you can have a single mode, which is monomodal, bimodal, trimodal, or polymodal. The mode is not really important if you want to know the truth about it, but it gives you points on a test. All right? Do not put 0 as a mode, okay? Because you always have that smart alecky teacher out there that even though you mean there is no mode by putting 0, that smart alecky teacher is going to say 0 is not even in the data set. Okay, so don't do that. Don't give a teacher a reason to be a smart aleck. Not applicable, does not exist, ain't there, there ain't there, any of those, but don't put 0. The number that shows up the most, if 2 and 2 shows up twice, and 4 and 4 shows up twice, then 2 and 4 is the mode. If 4 shows up 3 times and 2 shows up 2 times, then 4 is the mode. It's the number that shows up the most. Okay? And you can have more than one mode. Question on that? Alrighty. And we're going to go over this mathematically about 5,000 or 6,000 times in the next couple of days, so just bear with me. I'm going to give you all the numbers first. All the things first, and then after that we'll get into outliers after we do the empirical rule, but An outlier is your 300-pound second grader or your 6-foot second grader. Okay? Somebody that is not of the norm. Okay? A 9th grader that makes an 1800 SAT score. Okay? People that just blow the mind. Okay? I can't think of a lot, but I can, 600-pound, 300-pound second grader, 6-foot, 3rd grader, that kind of outlier. It's better to explain the outlier with the empirical rule. Of course, y'all are too stupid to know what the empirical rule is. This book does not call it the empirical rule. It's called the 99-66-23 rule, because y'all can't fathom empirical rule for some reason. I hate this book. Did I tell you I hated this book? Okay, I hate this book. Michael Jordan, is he an outlier? Yes. Yes, very much an outlier. Probably one of the biggest outliers in the NBA. Okay? And he got cut from a high school basketball team. Well, there's a page we can skip. Talks about the number of modes. I'm not going to get into that. I've done talked about that. Okay, skewness. It's always the opposite. There it is. Write these down. 368. These A, B, and C right here. You need to know the 3 skews. Symmetric, which means a bell curve, which means normal distribution. Or left skewed, which means all the data is to the what? Of center. Right. And right skewed, all the data is what of center? Left. Okay? Just remember the skew is the little part. So if it's left skewed, all the data is to the right. That means the hump is to the right. If it's right skewed, all the data is to the left, so the hump is on the left. It's always the opposite. I'd hate for you to get 3 problems on the test wrong because you didn't listen to me. Okay, there they are. It's always the opposite. Symmetric is when the center is in the center, and the bell is in the center, or the top is in the center. That's the normal distribution. They're getting you ready for the, I don't forgot it, empirical rule. That's what they're getting ready for. Variation. Spread out. Just remember, variation and standard deviation has to do with spreading out the data. Right now we're only talking about variation. I've done talked about variation. A's, B's, C's, D's, E's, and F, D's and F's in class. 6B must get into the empirical rule. 6B is where we're going to tie in everything together, and where most of your test is going to come from, if I'm correct. Measures of variation. Do we go into 6B next? Look in your outline. Or does it go to 6C? No, it's range. 6B. All right, write down page 374, the range. Your highest value minus your lowest value. So, whenever you're dealing with data, the first thing you do is put it in what? Order. You've got to put it in order. If you don't put it in order, you're not going to be able to find anything. Okay? And the definition of the range is the highest value minus the what? The lowest value. Write down the 5-number summary right here on page 375. I will go over that mathematically when we are doing the data. Okay? Write it down, know it. Low value, which is your minimum. Your lower quartile, which is your median. And then your median of the whole set. And then the median of the upper set. And then the highest value. Basically, you're talking about 3 medians and the range. the minimum and the max. And I'll show you how to do that in the when we put it all together mathematically. Box plot. Box plot is drawn with the 5-number summary. All you need to know is that, do y'all see the same thing I see? This is a book, okay? This is a text. Drawing a box plot. And it shows you how professionalism we're dealing with in this book. Drawing a box plot. Make sure you make a note of that, and we'll get into that when we do the math. Standard deviation. Do not even write this, because this is not the way you do standard deviation. I'm not going to give you this dummy down formula and you not know how to find the standard deviation. So just write standard deviation and put later. Range rule of thumb. I'm waiting for the empirical rule. How far do we go in chapter 6? See, that must be the empirical rule. I thought it would be B. Yep, normal distribution. Normal distribution, write that down. That's a symmetric bell curve. That's the one that's symmetric. And the skewed right, the skewed left is the one that's in the middle. Page 383. Here's the empirical rule. You need to write it down. I'm going to blow it up so you can write it down in your notebook. It's very important that you understand what this bit means. I'll let y'all write it down. Now those numbers on the bottom in blue, don't worry about that. Just draw the actual graph and I'll tell you what all that means. Now you can't call it the empirical rule because y'all have to call it the 95, 99.7 rule. It's a whole lot easier to remember that versus empirical. We've used 4 or 5 different books in the for 5 years, and all of the books have called it the empirical rule except for this book. Okay, so make sure you make a note of that. That is a test question, and not only is it a test question, but the reasoning behind it is used pretty much in your Unit 1 and Unit 2 test. So if you choose not to learn it, then you'll probably miss a lot of questions on both Unit 1 and Unit 2 based on this thinking. And that is that 99.7% of the population is going to fall within 3 standard deviations. Anything outside of 3 standard deviations is considered an outlier. 95% of the population is going to fall within 2 standard deviations. And 68% is going to fall within 1 standard deviation. So you need to make your numbers. This is 34. This is 34. This is 2.5. This is 2.5. And 34 is 68 plus 5 is what? 73, right? So that'd be 25, 27. And half of 27 is what? 23.5? No. Half of 27 is 13.5. Somebody help me out. Is that right? I always get this one, so I have to do it mathematically because I always forget. I want to put 11.5, 13.5, and 13.5. Now I will show you how that comes in handy when we get to doing the math. And I'm leading up to the math, but like I said, we're going to spend probably the next 2 meetings on nothing but math, which will make up 80% of your test. So just bear with me. If I try to teach everything in little sections, then you're going to forget half of it when we put it all together. All right, and that's the rule for that. Let's move on to what they call the 66, the 68, 99, 95, 99.7 rule. This basically says y'all are not smart enough to remember empirical, so we're going to call it this. There's the empirical rule again. It's just showing you the numbers, how they change with the problem. Okay, so let's take, I think that's it pretty much, z-score. Don't forget the z-score. I'll do the z-scores. We'll do the z-scores after I do them. So we still need to go over the z-scores. So Mr. Harvell and Ms. Lowry, don't let me forget to go over z-scores after we do all that we're talking about, the mean, median, and mode. So I'm going to pull up my handy-dandy Excel spreadsheet. Now, when I pull up the Excel spreadsheet, I'm not pulling it up saying, y'all all have to use this or you're going to fail the class. Okay, that's not what I'm pulling it up for. I am terrible at writing on the board. Okay, I'll start on one side, and by the time I get through writing the sentence, I've already covered up the first half of the board. Okay, I write big, I can't get everything on the board. Now, it's either I try to write on the board and I do 5 or 6 sheets, or I do the Excel spreadsheet and I can get everything on there because everything's the same size. All right? That's one reason I use it. Another reason I use it is I don't like using the calculator because next to Excel, the calculator is primitive. All right? So I don't like to use a calculator. If you like to use a calculator, knock yourself out. I'll show you how to use it after we do the spreadsheet. 3, I know there's some people out there that actually use the computer since it is 2017. And Excel is one of the best things since sliced bread. All right. So I do it for 3 reasons. 1, the presentation. 2, I don't like to use a calculator. And 3, there are some people out there that use it. Now, none of those say you have to use Excel spreadsheet or you're going to fail this class. All right. Every semester I get an evaluation in 120 and 103, and it says, Hubert expects everybody to know Excel. You are stupid. I didn't say anything about needing to know Excel. I said I use it for presentation. I don't like to use a calculator. And for those students that like to use it, you can use it. There's nothing in there. Yeah. Report. Every report is done by Excel. And when you see how easy it is, you're not going to use your calculator. Okay, here's my report. That ain't going to do anything. Yeah. And I was told when I was giving my first report to the president back in 96, 97, somewhere in there, one of the vice presidents told me, said, now when you go into this president's report, make your graphs on 3rd grade level. And you know, that stuck with me. And every time I give a presentation, I make sure I keep everything on a 3rd grade level, not insulting the intelligence of my audience. But when it comes to executives, when it comes to CEOs, when it comes to presidents, what do they want? Think of Donald Trump. Do they want this long, drawn-out presentation, or do they want you to get to the point? They want the bottom line, get to the point. I ain't got time to look at all this stuff. All right? And that's why the vice president told me, keep everything on the 3rd grade level, short and to the point. And Excel helps do that. So what we're going to do is we're going to go in here and I'm going to make up a data set X. Okay, and we're going to go with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 people in here. I'm going to make up ages. 18, 18, 18, 19, 20, 21, 21, 26, 26, 28, 27, and 29. Okay, cool. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we'll take off one of the 18s. Because it could be 17. We'll put 17. All right, there's our data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, all those are X's. I can't stand for everything to be on one of this. I've got to be in the center. So there we go. All right. Now the first thing I'm going to do is I'm going to go over here and I'm going to put mean. Mode. Range. Mid-range. Variance. And standard deviation. Now remember, there's 2 or 3 numbers in here that are very important. And I'm going to put them in green. I'm going to highlight that and I'm going to color it green for important. Median is important. And the mid-range is important. Now, the 2 most important numbers that you're going to want to know for the next 2 units, for this unit and the next unit, and I'll put them in outlines, is the mean and the standard deviation. Those are the 2 numbers that are very important for future. Okay? All right, so let's find the mean. Well, you got to add all these up and divide by what? How many are there? There's 11. And that's the mean. Okay, so everybody right now needs to take calculators out and add up all these numbers and divide by 11 and see if you get 22.91. Now notice, I'm not rounding off. If you round off at the very end. And I tell students to try to keep it to 5 digits. Okay? 5 digits or 4 digits, because usually most of the time you're going to be rounding to the 10th or the 100th. So 4 or 5 digits is good. The median. Well, this is odd or even amount? Odd, Hubert. That's right, class. So I'm going to pick the middle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there's the middle. I'm going to highlight that yellow. And yellow gives us the median. The mode. I really don't care about the mode, but what number shows up the most? 21 and 26? Yes. So I'll put 21, comma, 26. Range is equal to the highest minus the what? Mid-range is equal to the highest, write this down, highest plus the lowest divided by what? 2. The mid-range in algebra is also called the what? Anybody want to remember algebra? What's it called? Between 2 points. The mid what? The midpoint, Hubert. That's right, class. Y'all suck. Okay? The midpoint and mid-range is the same thing. You add the 2 numbers and divide by what? 2. Now, the variance and the standard deviation, you have to do a little bit of calculating. So I'm going to write the formulas up here for the variance, and I'm not going to assume that y'all are all stupid like the book does. I'm going to write out the formula that you're going to see in most of your textbooks. The variance is equal to the summation of x minus x bar, quantity squared, divided by n minus 1. And the standard deviation is equal to the square root of the what? The variance. So you need to read the formula. What do we need to subtract from each x? X bar. What is x bar? X bar is also called the mean. So what am I going to do? I'm going to put a title up here called x minus x bar. What are you going to do? Take 17 and subtract what? Mean, Hubert. That's right, class. It's y'all's interaction. Okay. Y'all remember that when you go to your boss, and your boss asks a question and you don't want to answer it, you just say it's Monday. Okay, well. All right, x minus x bar. What do we do with x minus x bar? You square it, right? So this is going to be called x minus x bar, quantity squared. I know it would help to have a parenthesis like this. R equals. Okay, I guess it's just not going to. Where is it?
Pull it back up.
I'm just going to do this. There. X minus x bar, quantity squared. And I'm going to take that number and I'm going to do what with it? And square it. Now, what's this big E mean right here? Sum. You're going to add it up. You're going to add those numbers up. So you go here, hit the summation, and add those numbers up. And that is your numerator of this number right here. So I'm going to put equals 188. Writing with the mouse is very hard. 9091 over, what's 11 minus 1? 10. So you just move the decimal what? Over one place. So 18.89091 is your variance. So I'm going to go down here and I'm going to say equals this guy divided by parentheses 10 minus 1 close parentheses. I'm sorry, 11 minus 1. And there is your variance. Now what is the standard deviation? The square root of the variance. So equals this raised to the 0.5 power. And there is your variance. I mean your standard deviation. Now I've just shown you how to find all of the things that you're going to need for this Unit 1 test. We're not through yet. Okay? The 5-number summary. I told you that you needed to know the 5-number summary. And I'm going to put it right here. 5-number summary. Don't worry, I'm going to go over this about 5 or 6 times. I'm going to do about 5 or 6 of these. And by about the 3rd or 4th time, you're going to say, okay, now we're going to do this, now we're going to do this, now we're going to do this. All right. The 5-number summary is made up of the mean, the first quartile, or first quartile, 25th percentile. It's called 2 things. It's called the first quartile or the 25th percentile. The second quartile or 50th percentile, or it's also called the median. Third quartile or 75th percentile. And then max. Well, the mean and the max is pretty simple. What's our mean? 17. What's our max? 29. What's our median? 21. I'm going to paint this that color, and 17 I'm going to paint it blue, so that way nobody can break this anvil with a banana, which some of y'all will be able to do. I don't know how. All right, so those numbers are gotten just by looking. Now, this guy right here is the median of these numbers. So how many numbers do we have above 21? 1, 2, 3, 4, 5. Odd or even? So you pick the middle. Sorry. Pick the middle. So I'm going to paint that one green. No. There goes something. There we go. And that's that number right there. And the same thing down here. 1, 2, 3, 4, 5. Ding. There it is. And we'll color that one some kind of rouge. Something. And that is your 5-number summary. Now there's a couple of things we can do with these 2 sets of numbers. One set we can do a box plot. This one we do the box plot, and I'll show you how to do that in just a second. This one over here we can do our normal distribution. So I'm going to erase this. And I'm going to draw a little line here. Let's see. 1, 2, 3. I'm going to do this. This. 1, 2, 3. 1, 2, 3. In the middle of our normal distribution is the what? The mean. Make sure you write this down and make sure you make notes, because this is where you're going to get a little bit confused when you go home and you're going to need to look on the video. Oh my gosh, I video my classes, don't I? That means y'all can see everything that I do in class. Wow, what a concept. Huh? Yeah, it is. It's recording. Okay. All right, now what am I going to add to this side? You're going to add the standard deviation on each side and subtract it on each side. So here we're going to add 4 point blah 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 to 22. I'm going to do it again. And one more time. Okay. Now, if I add it on the right side, what do you think I'm going to do on the left side? Subtract. That is your normal distribution. So now you take your handy dandy highlighter or your handy dandy pen and draw Y'all remember the empirical rule? So where's the outlier? Well, if we had an 8-year-old in this classroom, that would be an outlier. If we had a 55-year-old male in here, that would be an outlier. Okay? What about 14 to 31? 14 to 31 would encapsulate 95% of the population. Okay? So that's what the standard deviation and the mean gives you. It gives you the distribution of your data. Okay? Now, what does the 5-number summary give you? It basically gives you the same thing, only a different representation. In the middle, or first of all, you got to have a number line. And this number line has to have a beginning and a what? And the beginning is 17. And the end is what? 29. And the middle is called the mid-range. Mid-range is 23. Now, if you've never had to graduate a number line before, just take the midpoint of the midpoint of the midpoint of the midpoint. You can fill in as many lines as you want to. So, what's 17 to 23? 6. Half of 6 is what? 3, so this is 20. Or you can just add them together. 23 plus 29 is what? 42? Somebody help me out. 52? And what's half of 52? 26. Or you can just add 3 to both, whichever one you want to do. And then if you want to get between here and here, 1.5 is 19. 19.5, which is 19. You put that right there. And then 21 right here. 22, sorry. And then 23 to 26 would be 24, 25. And then 26 would be 27.5 or 28. Now, have I done anything with the quartiles yet? No. What I've done is just construct a what? A number line, Hubert. That's right, class. And now I'm going to put my box plot in. So I'm going to take my blue marker and I'm going to paint my 19. And my whatever color that is, I'm going to color that orange right there. That's 28. And then my median is what? 21, yellow. 21 is right in there. So that's my box plot. And that's how you do a box plot. So now you know how to do mean, median, mode, range, mid-range, variance, standard deviation, and the 5-number summary. So you need to work on chapter 6. This is 6D. Is this 6D or 6E? C. So now you should be able to work on homework 6A, 6B, and 6C. Online class and in class, you should be working on 6A, 6B, and 6C. That's after 5A, 5C, and 5E. So both my 103 classes should be working on 5A, 5C, 5E, 6A, 6B, and 6C. That's what both my 103 classes should be working on. Does everybody understand? All right, there was a couple of people that came in late, so make sure that y'all see me before class because I already called the roll. Rest of y'all, you got a lot of homework to do, so get to work. See y'all.